there are variety of methods in linear algebra to determine the solution sets. In our intermediate OA level, we studied the different methods like Cramer rules. So the main concept of all to determine the unknown values. If we see the detailed concept of unknown values, we can focus the matrix formation. This matrix formation can be discussed in two by two matrix, 3 by 3 matrix. If we are talking about 2 by 2 matrix, this shows that we are talking about the two-dimensional things. If we are talking about one row, or you can say one vector, it means one-dimensional things. Audio signal, two-dimensional means images or some kind of pattern where we are requiring only x and y axis. Three-dimensional, you can say volumetric kind of things. So, in two-dimensional case, we need two equations. Two equations represent two problems. The nature of two problems belong to the same domain. Okay. So, if we see 2x minus y equal 0, if this belongs to some pattern that is representing one vector, other you can say 2y equal 3. This represents another set of problem in terms of equations. So we can accommodate this in terms of 2 by 2 matrix, like where these are the matrix with its coefficient form. Usually we represent it with A, and these are the unknown vector of unknown, and this last vector can say constant coefficient of constant. So in usual expression we can write where x is, you can say, usually represented to determine the unknown value. That is representing how to determine the solution set. Here, if we picturize it in the vector form, we can consider in two ways. First one is a row picture. Row picture, we want to see this in row formation. We need to make a graph like this, okay? X minus y equal to 0. So here, if we are going to draw in some graphical notions, for getting value of 0, of course, if we are considering x equal to 0, y equal to 0, of course it is equivalent to 0. So here it is passing through the region. Now, if we are considering some, okay, more cosmetic surgery, if we are considering x equal to half, then again we will get this 0 and 2, 1 over 2. But for this, if we are using x equal to half, then we should use y equal to 1. Then similarly, okay, here if we are considering this 1 over 2, so y should 1. This is the another point. If we are considering x equal to 1, in this case y should 2.
2.
Yes, sir. 2. Yes, sir. Okay, thank you so much. if we are considering here 1, in that case y equal to 2. So this is representing some kind of line. Now in this row picture we are considering only the first notion of a problem. You can say first equation. In previous lecture I told you, for get a solution set, we should know the point of intersection. Now we have another equation, okay? That is minus x plus 2y equal to 3. For determining its graphical notion, we can suppose if x equal 0, y equal 0, so in this case passing through the origin is not
be possible.
Possible or not possible?
So not possible.
Okay, for getting this 3, what we can assume? We can assume 3.
X.
Okay, let me change.
1 into 2.
Okay, if we are considering
X is equal to 1.
y equal to 0, okay, y equal to 0,
Sir,
then
x minus 3.
सर पहले x को नहीं कंसीडर करते हैं.
yeah, if we are considering x equal to minus 3, y equal to 0, then we will get what? At this point, so 1, 2, 3, we will get this is the first point. If we have this, then equation will be satisfied. Similarly, if we are proceeding a little further, we can say if x equal to minus 1, yeah.
So 1.
And what should be the value of y?
Sir, x
2.
is not.
Or y equal to 1. Y equal to 1, then answer should what?
3.
3, okay. In this case,
1 minus 2.
y equal to 1, so at this point. Is it okay?
Yes.
Now, more, okay, this is generalized. Because you people are grown up, okay, you can generalize different assumptions.
1 into 2.
So,
X is equal to
1,
1. And y is equal to 2.
and here 2. So, if x is 1, y is 2, so at this point. My children, now we have 3 different points, okay, for both of equations, but we can notice only this point. There.
So next slide.
This one.
So next slide.
Next slide.
Really? So next slide.
No. Here, let me consider the point. 0, 0. Here 1. Here 1, 2. So this last point is similar to the next one. Is that okay? Two equations are different. But for getting the point of intersection, we picturize the rows and we observe that at this point they are overlapping. So remember, okay, in this case line is passing through the origin.
1, 2 is the point of intersection.
This is the first row. Row 1. If we are talking about the row 2, this will, of course, this is, okay, this is generalization. So, represent row 2. And the point of intersection is this one. This is our solution set. Is it okay?
Yes.
This is the row picturization, because being a computing student, you need to determine at what point we can get a solution set. The process of Gaussian elimination process, reduced row echelon form or Cramer root, every method is required for this purpose, that to determine the point of intersection. So this one was, you can say, it is kind of a row. Now we can see the column picture. Similarly, you can determine, you can satisfy the problem nature with the help of column picture. And if I consider the column picture from this, okay, this set here, I explain the trick at the later stage, but we can write the matrix notion in form of x y minus 1, and this is the. So basically, again we need to picturize it in terms of vector, okay? So here x and y are performing a linear combination operation. So this one, these both are the linear combination in this formation. So how we can get this one? Let's draw a picture. The first place, of course, our main purpose to produce the vector 0, 3, this one. So if we are considering the first, this one, okay, here this is a vector. Graphical notion for the first value of x here. If we are having x 2 minus 1, for the value of, once we are assuming simple, okay, simple formation. If we are considering x equal to 0, then nothing, okay, we cannot determine, we cannot make any vector from this, because it's a scalar value. It is acting, this variable is acting a scalar value for this vector. So we are considering, yes please?
So magnitude there.
Yeah, this is somehow, but we need to draw vector. For this we will start from the 1. Okay, x equal to 1, then of course for drawing of this vector, you can say, oh, okay, for even you can get a start from the some origin, but of course for x is what? First element is representing x-axis, second element is representing
y-axis.
So for 2, what is the value of y? Is negative. Negative. So at this point somewhere. Is it okay?
Yes.
Or you can say, we are talking about the region, it is going like this. Danish?
Yes sir.
Start, okay, from the region you can consider.
इससे तो ये एक point है.
Yeah, exactly.
तो हमें एक और point भी हमारे
yes,
minus 1 or 2.
Yes, exactly. Minus 1 or 2. Again, we are considering here, in this situation, for drawing a vector of minus 1 and 2, of course, it is going into the, okay, value of minus, yeah, let me, minus 1, 2.
सर
Yes, please.
सर ये -1 पीछे नहीं होगा क्योंकि ये x एक्सिस है, आपने उसको y एक्सिस के अलॉन्ग दिखाया है.
This is one, this is representing x-axis, this is representing y-axis. X-axis my child, 1, 2, y-axis minus, okay?
पर सर जब इसको हम वो इक्वेशन फॉर्म के अंदर लिखेंगे तब -1 और 2 वो तो मैग्नीट्यूड है एक्सिस के.
Let me explain, okay? Here, if we are making drawing the vector for this, what should be the value here?
-1 yeah or
This
2.
is x-axis.
Yes.
-1
and 2.
and here 1, 2. So at this point, so you can say end of a line.
Okay, so we can consider
But the problem is this: where is 0? This one. Where this vector, this will lie. You need to multiply its mean. For getting this one, we should multiply, or we should assume x equal to 1 and y equal to what? Y equal to 2. So here, then it will satisfy this equivalent to the output our constant coefficient. So your coefficient in this situation will be, and here your matrix, you have this last coefficient of constant 0. What is the coefficient of constant? X is 0. Once x is 0, then y is 3. Okay. So this is the representation of the column, okay, column formation of this matrix. What this represents linear combination? For example, somewhere the signal, or you can say tower, or you can say that the U-phone tower at this place, and another U-phone tower at this place. The person who is standing somewhere in middle can get a signal. Linear combination. Are you getting the point?
Yes.
So you need to compute the model that if you are going to place U-phone towers in some certain city, at what position you can locate them for getting a better signal strength. So you should compute with the help of programming language. But this is a simple model. You can make 3D, 4D, 5, okay? In certain planes, you can determine. Is it really difficult?
No, sir.
Before this, you familiar with the matrix multiplication? This is somehow, I would like to explain it simple. For example, this one is some matrix. You want to multiply with some, okay? Row-wise multiplication is similar to the column-wise multiplication. A moment ago, I did column-wise multiplication. For example, this is the first element. First row, first column, plus second row, second row. Yeah, this is column-wise multiplication. Otherwise, you can go like this way, okay? You multiply with element-wise multiplication. So it's up to you. Nothing is difficult. Is there any query?
No, sir.
Okay, I observed many students performed okay, the quiz in a very wrong way. Few people don't know the vector formation, how you need to multiply, how you are going to picturize these basic vectors. This is problematic. Okay, in your future you will get into trouble due to this reason. Let me explain one example here. This example, the example of linear algebra application is okay, electrical circuit. For example, we are considering some electrical circuit with some resistors in ohms. These resistors you can say electric bulb. Electric bulb is also kind of a they are glowing due to resistance.
Yes.
So though it is look like electrical model, but it is for understanding, okay? Because you are a computing student, you should know the problem, how it can be tackled, how it can be formatted in the mathematical equations for making a better algorithm. It is very much important. Current in amperes and voltage in volts. So this is a diagram for simple understanding. Now, what are unknown in this picture?
One resistance.
नहीं current.
Brilliant, very well done. Unknown, yeah, you can clap. Okay.
एक clap इस तरह दिया है.
Unknown are current. Like we are determining x1, x2, x3. Here we should know what's the I1, I2, I3. Just okay, labeling.
Just labeling, yes sir.
Nothing else.
Yes sir.
But this is a real life problem. How you compose this real life problem in terms of equations? How? First of all, a moment ago in the last example, I talked the similar nature of problem should be composed in one matrix. Here there are three unknowns. All nature of all unknowns belong to the current. Is it okay?
Yes.
So we can compose in a single matrix.
Yes, we can see.
And for this, how many equations we can develop? Three. Why? Because there are three different loops. First one, second one, third one. Or you can say three different circuits. In three different circuits, you can compose three different
Yes
equations.
sir. Yes sir.
For I1, we are considering this voltage is kind of a source voltage. And if I am going to explain that this one is the resistor 1, or you can say bulb 1, and this one is the resistor 2, is also attaching to this. Let me use the one color for this. Okay. This one, this one, this one, this one, everything is associated to the first equation. Here, how I can get rid of this? Okay, no, that's okay. 7 is what? Source voltage?
Yes.
1 is
Resistance.
resistance. Here, okay. Now we are using the negative. Whatever this bulb or this resistor get, it will be subtracted from the main voltage. So negative sign here. This negative sign here.
Resistance there.
Now, what is the I1 minus I2? See,
So क्योंकि वो intersect में.
this one is the current one, okay?
और
Here
ये-
current is sharing with this loop, so
Yes.
with I1, this subtracted I2.
I do.
This one.
Yes.
Now, this one is another. Voltage,
Yeah, yeah,
because it is subtracted from the main power system. Negative sign. This is negative Again negative sign
because of resistance.
here
Resistor.
this one resistor, negative sign. So now this current I3, again you can check here, again like this, similar like this, but here the resistor you can see strength is 2. Okay, if you say this one is the 1 volt or resistance is 1, is double than the previous one. It is getting more current from it. So we are considering this. So overall net we are writing it equivalent to 0. This is the first equation of this. This is now if we are going to make an equation for this. So this one of course
Minus we got
minus,
resistance.
and of course here remember it is becoming positive I2. Why? Because current at this point I2 in this loop is entering, okay, and leaving here, it is leaving. Okay, so I1 from this loop it is subtracted away. It is subtracted away.
Yes.
Again
2 minus 2 because of
this, it is alone. So from this current of it is only dependent upon the I2 loop, but it is again getting this bulb is going, so getting some current, so my negative sign. So the third one
by the way
here,
pictures
this one
pictures
subtracted away from the this, it because it is sharing.
yes.
So this one is representing the second loop. Similarly, now in this case,
Sorry, by the way, want to negative 2
so you are considering again in the same formation and third equation. This is the, now you can construct a 3 by 3 matrix because you have to know about 3 unknowns. On further simplification, you will get answer of this. If I say you can but these values are kind of a constant, and what you need to know solution set in form of y. This is the point for determination. You can apply any Gaussian elimination process, reduced Torsion form, Cramer rule, whatever. You need to determine this unknown. And this unknown, of course, I1, I2, I3. If you think it's really difficult, please let me know. Otherwise, solve it right now. Right in class. Yes, right.